Alright, Cam. So, we're going to do a lesson on fractions. Okay, lesson. Sorry. Okay, first thing we need to know is a couple of key terms. So, let me just zoom in just a bit. Okay, so key terms I'll be writing in blue. So, key terms are going to be in blue. First, we need to know what a fraction is. And a over b is a fraction. A and b are going to be numbers. Okay? So first of all, we need to know what the heck is that thing? That's the division bar. Fractions are numbers divided by numbers, right? So this one is a divided by b, right? What is the a? Well, the a, or the number on top, is the numerator. And I'm going to write numerator in big letters so you don't forget numerator. Sorry. And the number on the bottom, that's going to be the denominator. Denominator. D-E-N-O. Minator. Alrighty. Okay. Now, fractions can represent a lot of things. So usually fractions are what people would call, key terms in blue, parts of a whole. But that's not always the case, because we have something called an improper fraction, and that is when the numerator is greater, so greater sign, than the denominator. So if you really think of just two numbers, let's say the numerator will be 3, so then we just think of a number less than 3, and that goes in the denominator. So that's 2, so 3 over 2, improper fraction. Okay, that's about it. That's pretty much the basic knowledge you need to know. So let's start doing some adding and subtracting. Alrighty, so let's say you have two fractions. We'll just do 1/2 plus 2/3. Pretty simple one. If you think about maybe a candy bar, okay, and I'm gonna split this up into 6, and you'll see the reason why I split it up into 6. 3, 4, 5, 6. Okay, imagine they're all equal. If I had 2/3, so 2/3, so this is a third, and a third, right? So I had 2/3, so that I'm gonna color it yellow. So 2/3, right? So I had this much candy bar, and then someone gave me another half. Someone gave me half. Let's see. Half would be what? 3 of these bars, right? Half, and then this would be another half. That makes a whole candy bar. We're going to color this one blue. So if I got another half, well, how much candy bars did I receive? You can already see that if you add the green and the blue, the yellow and the blue, you got more than one candy bar. So you have already more than one candy bar. But how much exactly do you have? Well, if you look at this, each slot is so one slot is a 6. So why don't we count how many sixths we got? So for the yellow has 1, 2, 3, 4. So that's the yellow has 4 sixths. And the blue got 1, 2, 3. And that's going to be 3 sixths. So together, how much did you get? 1, 2, 3, 4, 5, 6, 7. Got 7/6. I know the picture is kind of hard to see, but here, if I made 2 candy bars, it'd be a little bit easier to see. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So remember, we would have 4 yellows. So 1, 2, 3, 4, and then 3 blues. Right? So 1, 2, and then 3. So I would have, you can see here, by all of this, 7/6 of a candy bar. Now, how do we do that without looking at a picture? Because a picture takes too long to draw. So, here's what we need to do. So let's bring back the problem. So problems I usually do in black. So 1/2 plus 2/3. Now I'm going to do this thing, it's called a note. We do this in red. This is going to help us along the way solve the equation. So when adding or subtracting fractions, the denominators need to be the same. So now, remember, denominator is what? The bottom number. Bottom number. Alrighty, so let's look at the bottom numbers. Are they the same? Question mark. No, they are not. No. So we need to make them the same. So how should we do that? We need to find what is called, it's going to be a blue term, the least common denominator, or we call it LCD. Your teacher might refer to it as that, but this stands for least common denominator. Alrighty. So the least common denominator is actually the least common multiple. LCM. Least common multiple. Now what is the least common multiple? Now we'll get into that. So we're going to take the 2 denominators. We put them here. So we have 2 and 3. Looking at the least common multiples, so we're just going to do a few. So 2 times 1 is what? 2. We're going to do 2 times 2, that's going to be 4. 2 times 3, that's going to be 6. 2 times 4, that's going to be 8. And 2 times 5, that's 10. We'll stop there. Now we do 3's, right? 3 times 1 is what? 3. 3 times 2 is 6. 3 times 3 is 9. We can actually stop there because we found a similarity. Right? What's the similar number here? 6. Right? So we're going to take the number. Remember, this was our original denominator. This is our original denominator. What we're going to do is we're going to multiply it by 3. And we're going to multiply this denominator by 2. So that we both end up with 6's. Alrighty? So now, this one you have to watch very carefully because it gets a little confusing at this point. Since this is 2, and we want 6, we need to multiply by 3. So we're going to multiply by 3 over 3. I put these parentheses, but they really mean just multiplication. Now, why do we multiply by 3 over 3? I thought we just needed to change the denominator. That is true. But, so we don't change the fraction, we need to multiply on the top and the bottom the same number. because, so I'm going to do another note. We multiply both top and bottom, and by the same number because we must keep equality. This is a big thing. Equality. So we cannot change the original form or the original problem, really, because we're not changing anything by multiplying 3 over 3, because 3 over 3 is what? How many times can 3 go into 3? 1, right? And 1 times any number, so I'll call it x. X times 1. Ooh, maybe x is a bad example. But a times 1, so any number a times 1 will always be the same number. So there's not a change. That's why we multiply the top and bottom by the same number. So with that, right, we have what? 3. But we want 6, but we need to multiply by 2 to get 6. So I'm going to multiply this side, I should do it here, times 2 over times 2. Remember, 2 over 2, because that's equal to 1, and we don't want to change anything. Alrighty, now we can just multiply across. So 1 times 3 is what? 3, right? 2 times 3 is 6, because that's what we wanted. 2 times 2 is 4, and 3 times 2 is 6. Alrighty. Now how do we combine fractions? So this is the step that we need to know. I'm going to do it in green just so we remember. We combine. And so now that the denominators match, you can put the whole function here, so 3 plus 4, over the one denominator. So these become what? 3 plus 4 over 6. Now, this is just simple math, because 3 plus 4 is 7 over 6. Okay, that's our first answer. And does it match? Let's check. So we can see that 7 over 6, that's correct, because we have 1, 2, 3, 4, 5, 6, 7. 7 1/6 pieces. So it makes sense. Okay, so let's do something a little harder. So let's see, a little harder. Now we're gonna try and compare fractions that maybe have more than 2. So let's say we're gonna add more than 2. So we'll do 1/2 plus 1/3 plus 1/4. Well, what does that equal? Well, we're gonna find out. Ooh, actually, let's do subtraction, because we haven't done subtraction. But what is the first thing that we always look at when adding or subtracting fractions? So let's write that down so we don't forget. What is the first thing we look at when adding? So I'm going to use plus, or subtracting, we're going to use minus fractions. It is the denominator. That's right. Or bottom number. We must check if they match. Okay, so the denominators must match. Do they match? 2 and 3 and 4. Sure, they're nice in a line, but they do not match. So don't match. So we need to change that. Alrighty. So let's list some multiples. 2, 4, 6, 8, 10, we'll do 3, 3, 6, 9, 12, 15, 4 is 4, 8, 12, 16, 20. Okay, so, I need to go one more and 2, and I get 12, and now I can see a match. We've matched. But sometimes this takes too long, so we need to find a new way. Alright. So, in general, okay, I'm going to go a little bit sophisticated here, so just go with me. Note, for some fraction a over b plus c over d, a common denominator will always be the distinct meaning the different denominators multiplied together. Now, I said common denominator, not the least common, because sometimes the least common is actually less than the two distinct denominators multiplied together. But what does that mean? I'm just going to multiply this whole thing by d over d, this whole thing by b over b, and it works out. So get AD plus BC all over BD. Now this will always work, right, for every one number. And sure, sometimes they might get way too big, but you know, that's the risk you take for going so fast. So you have 1/2 plus 1/3 minus 1/4. So if we use this formula, we're going to take this denominator and we're going to multiply this fraction by what's missing, right? So it's missing a 3 and a 4. So I'm going to multiply it by 3 times 4 over 3 times 4. Now 3 times 4 is just 12. So 12 times 1 will be 12, and 12 times 2 is 24. Alright, now we do the same with the other fractions. So this one, 1/3, is actually missing a 2 and a 4. So we're going to do 2 times 4 over 2 times 4. And 2 times 4 is 8, right? So we're going to get 8 times 1, which is 8, over 8 times 3, which is 24. Ready, bring down the minus sign, bring down the plus sign, sorry I should put that. Minus, the sign shouldn't really change much. Let's see, 1/4 is missing what? A 3 and a 2. So we're going to multiply this side by 2 times 3 over 2 times 3. And that's going to be 6, right? And 6 times 1 is just 6, and 6 times 4 is 24. Do we have matching denominators? We have a match. Yes. So now we just put the operations and the numerators in one fraction. So 12 plus 8, don't forget this was a minus 6. Alrighty, all over 24. This is going to be, what, 20 minus 6, that's going to be 14 over 24. This can be simplified, but we will go over that in the next section. Okay, so we can leave our answer like this and that'll be fine for now. So let's do some advanced math. So hold on to your seat for this one, because guess what, Cam? We're going to do some advanced math. So x over 3 minus 2/4 is going to be 1 over 12. We need to figure out what x is going to be. So we're going to solve for x. Alrighty. So how should we solve for x? Why don't we combine this fraction first? Maybe it might give us some tricks, right? So combine. So, do they have matching denominators? They do not. Don't match. Okay, so remember, we have x over 3 minus 2 over 4. We're going to multiply this side by what it doesn't have, so that's going to be 4, so we're going to multiply on that side. 4 over 4, and this side doesn't got 3, so we're going to multiply this by 3 over 3. And what do we get? Right? We get 4 times x, that's going to be 4x. And 3 times 4, that's just 12, minus 3 times 2, that's going to be 6 over 12. Now, this is all equal to 1 over 12, because we have that here, and we must bring that down. Remember, we can combine this fraction now, and we'll get 4x minus 6 over 12 is equal to 1 over 12. So, since we have 4x minus 6 over 12 is equal to 1 over 12, we have this here. Since the denominators are the same, we can kind of just get rid of them. So, we're going to scratch them out. Better explanation next section. But, okay, so we're going to get 4x minus 6 equals 1. And now we can solve, right? Because we add 6 plus 6. So 4x is going to be equal to 1 plus 6. That's what? 7. Ready? And then we're going to divide by 4. So x is equal to 7 over 4. Wow. A fraction. Proper or improper? Let's see if you're paying attention, Cam. So, which one is it? A proper or improper fraction? Yeah. Remember, since 7 is greater than 4, it's going to be a improper fraction. And I'll go over that in the next video on how to make a mixed number. Yeah, that one I'll go over in the next video. Alrighty, so now you kind of get the gist of what a fraction is and how to add and subtract them. So, if you don't know, now you know. Okay,